Hey, welcome back, guys. I've got some problems now that I know you're really going to like. It involves algebra and solving the equation, all that kind of good stuff that you guys love so much. All right, so here we go. It's more KSP problems, but now we're dealing with a situation where we don't know the concentrations. We're calculating those concentrations. So I chose FeOH by 2. FeOH by 2 has a KSP of 4.9 times 10 to the minus 17th. Our job now is to calculate the molar concentration of FeOH by 2 in a saturated solution. So now we don't know those molarities to start with, which makes things a little bit more tedious. We're going to set up an ice table. All we'll have are ice tables for regular KSP problems. So for FeOH by 2, we always write them with the solid on the left because we're showing the reaction as they dissociate into make some ions. So 1 Fe 2 plus because there are 2 hydroxides, plus 2 OH minuses from the formula. Now under initial conditions, when we just put in some FeOH by 2, all that's there is FeOH2 by as a solid. Solids never show up in the ice tables, right? We ignore them. There's no Fe2 plus or OH minus because we just now put it in. Next up, the change stage. Don't worry about the FeOH by 2. It's a solid. We gain X amount of Fe2 plus because there's a 1 up there, plus X and plus 2X for OH minus. So at equilibrium, we're still not worrying about FeOH by 2. We got X and 2X for Fe2 plus and OH minus respectively. Now, if you remember what we did with this in the Kc problems, we plugged these into the Kc expression. We're going to do the same thing again. There's just nothing to do for the denominator because it was a solid. So KSP for these, this would be concentration of Fe2 plus times OH minus squared. And that has a numeric value of 4.9 times 10 to the minus 17th. So we plug in our algebra expressions into KSP. So Fe2 plus is X. OH minus is 2X quantity squared. Remember all the trouble we had with that back in the regular equilibrium chapter, right? When we square that, it becomes 4X squared for that term. So I'm going to simplify what's on the left-hand side. X times 2X quantity squared is 4X cubed, right? We get 4X squared from that times X. 4X cubed is 4.9 times 10 to the minus 17th. So X cubed is 4.9 times 10 to the minus 17th over 4. So X cubed is equal to 1.225 times 10 to the minus 17th. So X is the cube root of what's on your screen. So y to the X, 3, and 1 over that to get the third power, to the 1/3 power, equals 2.31 times 10 to the minus 6th. That's molar. 2.31 times 10 to the minus 6th. So then at the end, we have to recognize whether X really is our concentration or not. Does X represent the molar solubility, the concentration of FeOH by 2? X, we know from the ICE table, is a concentration of Fe2 plus. Sorry, I'm off the screen a little bit there. It's Fe2 plus. And since there's one iron ion per FeOH by 2 formula unit, that means that the concentration of Fe OH by 2 equals 2.31 times 10 to the minus 6 molar. That is the molar solubility of iron hydroxide and iron 2 hydroxide in that solution. So some other things you might be asked about this problem that makes it the same kind of problem. You might be asked, what's the pH of a saturated solution? Good question. We'll come right back to that with the next video, okay?